So this question says, consider the following reactions we calculated the standard potential for earlier. Calculate delta G and K for these reactions. How do these three values relate to each other or relate to the spontaneity of the reaction? Okay, so let's take a look at these ones. So we did Ecell equals E naught reduction minus E naught oxidation for both of these reactions. And in this one, we found that E naught of the cell is equal to 0.784 volts. And for this one down here that we'll do in a minute, we found that the E naught of the cell is going to be equal to 0.6356 volts. Okay, and we did this by doing E naught of reduction minus E naught of oxidation using the table here. Okay, but we already did this in previous questions, so you can go back to those questions if you're not sure how to do that. Now we need to convert this to delta G and K. First thing I want to talk about is a little bit about the spontaneity. So since here E cell is positive, it's spontaneous, and the same thing here. So what are the equations? Delta G naught equals minus N, the number of moles of electrons transferred, F, which is Faraday's constant, times E cell. Okay, this will give us the value of delta G. We can also find K. E cell equals 0.0592 volts divided by N, the number of electrons, times the log of K. So if we have a reaction where the E cell is positive, meaning it's spontaneous, we would expect that the delta G is negative. What about K? We would expect that the K is a big number. Why a big number? Because remember that K is products over reactants. So if you have a whole bunch of products and not very much reactants, that's going to be a reaction that's spontaneous in the forward direction. And if you have a whole bunch of products and not much reactants, then your value of K will be a big number because it's products over reactants. So let's go ahead and plug this in. The first thing we have to do is we have to see how many moles of electrons are transferred. Well, in this case, we have Cu2 plus yields Cu, and Fe yields Fe2 plus. So we have 2 moles of electrons transferred. It also tells us that here. All right, there's a 2 here that shouldn't be there. So now we have to do delta G naught equals minus 2 times F, which is Faraday's constant, which is 96485 coulombs per mole. All right, times the E cell, which is 0.784 volts, and a volt is a joule per coulomb. When we do this math, we find that delta G naught equals minus 151,000 joules, or minus 151 kilojoules. Positive delta E spontaneous, or excuse me, positive E cell is spontaneous, negative delta G is spontaneous. Now how about this one? And this one is very similar. We can plug in the E cell, which is the 0.784 volts equals 0.0592 volts over N. It's again 2 moles of electrons times the log of K. All right, so in this case, what we're going to do is we're going to divide these out, and then once we've divided this out, we're going to divide this by the result of that answer. And what you find is that log of K is equal to 26.5. Now we need to get rid of the log, so we take 10 to the log, and we take 10 to the 26.5, which of course is going to be a huge number. And K is equal to 3.07 times 10 to the 26th. Okay, so we end up with a very large value of K because we have here a large amount of product and a small amount of reactant. Said another way, it's spontaneous in the forward direction. All right, so the question below is exactly the same thing, okay? We again have 2 moles of electrons transferred. We found the Ecell in a previous question, so we can just plug in. Delta G naught equals minus N, it's 2 moles of electrons, times Faraday's constant, 96485 coulombs per mole, times the in this case the Ecell is different than in that case, so it's going to be 0.6356, and that's joules per coulomb or volts. It's the same thing. Okay, and when you do that, you find that delta G is equal to minus 122,700 joules, or minus 122.7 kilojoules. Again, E is positive, so it's spontaneous. Delta G is negative, so it's spontaneous. We then need to do this one over here. So Ecell is equal to 0.0. Let me just plug in. The Ecell here is 0.6356 volts equals 0.0592 volts over N, again 2 moles of electrons are transferred, times the log of K. Again, divide these and then divide that answer into this one, and we get the log of K is equal to 21.5. 10 to the log gets rid of the log. 10 to the 21.5 gives us that K is equal to 2.97 times 10 to the 21. Again, a very large number for K means we have a lot of product and not very much reactant, because again, K is products over reactants. So that is how delta G, Ecell, and K are related to one another.